Hi everyone, in this video we will cover the most important principle of object-oriented design, the building blocks of writing clean and scalable code. Let's begin with a quick introduction to object-oriented design. Object-oriented design is a programming paradigm that focuses on creating objects and how these objects interact with each other via some methods. Each object holds data and exposes behaviors to modify or retrieve the data. Encapsulation. Thinking of it as putting data in a box and locking it. Encapsulation hides internal details of an object and exposes only what's necessary. It combines data and methods into a single unit known as the object. The key benefit is control. You decide how external code accesses or modifies data. Here's the code for encapsulation. We have made balance private and provided public method get balance deposit to control access. This method allows us to create checks before modifying the data, like validating the amount. Abstraction. Focus on what and not how. Abstraction hides complex internal logic and exposes a simple interface. We use abstract classes or interface to define the what. It promotes loose coupling, allowing components to work independently. In this code, the abstract class animal defines make sound without implementation. Subclasses like dog or cat define how the sound is made. The user doesn't need to know the internal details. Inheritance. Pass down properties and behaviors like a family tree. Inheritance allows one class to inherit properties and methods from another using the extends keyword. This promotes code reuse and supports hierarchies of classes. Here's an example. Car extends vehicle and inherits the start method. No need to rewrite it. Polymorphism. One interface, many implementations. Polymorphism allows the same method to behave differently based on the object calling it. There are two types of polymorphism: compile time, also known as overloading, and runtime, also known as overriding. Here's an example of compile time polymorphism. The add method is overloaded once with int, once with double parameters. The method chosen depends on the argument type at the compile time. That's why it is known as compile time polymorphism. And now, runtime polymorphism. We have an animal class with a sound method. Dog and cat overrides it. When you call sound on an animal reference, the method that runs depends on the actual object. That's dynamic method dispatch in action. Modularity, divide and conquer. Modularity breaks a large system into smaller, focused components. Each module handle a specific responsibility, leading to better readability, maintainability, and testability. In this example, we have a payment module and an order module. Each module handles its own concerns independently. Perfect modularity. Association. A uses a relationship. Association is when two classes are logically connected but can exist independently. For example, a driver uses a car, both can exist without each other. Here's the code. The driver class has a reference to car, a simple and clear association. Aggregation, a weak has a relationship. Aggregation is when one object contains another, but both can exist independently. For example, a team has a player. Player can exist without a team as well. Here's the code. The team class contains a list of player objects. You can reuse players across teams, and players don't depend on teams for their existence. Composition. A strong has a relationship. Composition is when one object cannot exist without the other. For example, a house has a room. If the house is destroyed, the room no longer has any meaning. Here's the code for the same. Inside the house class, we create and manage the room. There's no external way to create or reuse room without a house. Low coupling and high cohesion. The golden rule. Low coupling minimizes how much classes depends on each other. High cohesion on the other hand, each classes should only do one thing and one thing very well. These two principles leads to clean, maintainable and modular code. Here is the code example. Order service and payment service each have one responsibility. So this promotes high cohesion. We inject payment service into order service, reducing dependencies. That is, we have low coupling here. If you are new to dependency injection, check out the solid principle video linked in the description. These principles help you write code that is scalable, reusable, testable, and easier to maintain. That's all for this video. Thanks a lot for watching. Don't forget to like, comment, and subscribe to the channel.